column 1, we're asked to find the basis for the solution space of this system of equations. And so remember, what we need to do is basically set up the matrix to solve this system. So there's my augmented matrix. I'll add negative row 1 to row 2, and that'll be my new row 2. So this top row stays the same. The bottom row becomes 0, minus 2, 1, 0. And then I can't really go any further. I'll get my solution from here. You can make a fraction out of this if you like. You don't have to get a 1 there, but I'll just say this bottom equation, I get minus 2x2 plus x3 is 0. And so if I let x3 be t, then from here you can see that x2, well, I'm going to bring the t over to the other side and then divide by negative 2. So this is going to be 1/2 t. And then plugging both of those back into the first equation, which is right here, I'm going to have x1 plus 1/2 t plus t equals 0. Well, that's going to be 3/2 t, so x1 is going to equal minus 3/2 t. So my solutions look like this. They're minus 3/2 t, 1/2 t, and t. If I take the t out, get minus 3/2, 1/2, 1, which you can use, or you can go even further and take out a half with it just to make it look nicer. You don't have to do this part. If I want integers in there, if I take out a 1/2, this will be minus 3, 1, and this would be 2, because when I multiply the 1/2 back in, it needs to get back to 1. And so this would be my basis vector. That's all I have for the basis, is a single vector in this case. Any solution to this system has to be a multiple of that vector. Or if you like, this vector, but any multiple of this vector would also be a basis. Okay, here we've got a situation where we're given 3 vectors, and we're told that they're a basis, but explain why they form a basis. Well, to be a basis in R3, we need 3 vectors, exactly 3 vectors. Can't have more, can't have less, or it wouldn't be a basis, so that's part of the explanation. And they have to be linearly independent. And so to check if they're linearly independent, I put them in a matrix as the column vectors of the matrix. And I take the determinant of that matrix. Well, it's easy enough to just go across this top row. I got 1 times the determinant of minus 1, minus 1, 0, 1, minus a minus 1 times 1, 1, minus 1, 1. If I do these, this is going to be minus 1, minus 0, so this is going to be minus 1 from that first one. And then this turns into a plus. Here we're going to have 1 minus a minus 1, so that's going to be plus 1 minus a minus 1, that's 2, which is 1, which is not 0. And as long as the determinant's not 0, we know that these vectors are linearly independent. So they're linearly independent. And in R3, if you have a set of 3 vectors that are linearly independent, that's enough to say they're a basis. You don't have to verify the spanning part that is part of the definition of a basis. So 3 vectors in R3 that are linearly independent, they are a basis. And so now I can set up the system of how these 3 vectors, so it would be some C1 V1 plus C2 V2 plus C3 V3. I want that to equal this vector U. Well, that leads to the following system: 1, 1, 1, minus 1, minus 1, 0, 0, minus 1, 1. And I want to set that equal to 1, 2, 3. So I solve this system. I'll take minus row 1, add that to both row 2 and row 3. to get my new row 2 and row 3. So minus row 1, it's going to give me a 1, 0, 0 like this. Here it's going to become positive 1, so this will still be the same. Let me write it down so I don't forget. Anyway, this will be 0. This will still be minus 1, and this will be minus 1 plus 2 will be 1. And then down here, this will be 0, like I've got, and then I've got minus 1 becomes positive 1, so there's a 1 there. And then this will still be 1, and minus 1 plus 3 is 2. And this is actually enough to solve the equation, because if you want to switch these rows, you can, but from here I can see that C3 needs to be negative 1, because negative C3 is 1, because that's my variables here, C1, C2, C3. And then if I know C3 from this one, I've got that C2 plus C3 has to equal 2, so that means C2 is going to equal 3. And then plugging that in here, that top equation says that C1 minus C2, so C1 minus 3, is supposed to equal 1. So that's it says C1 is 4. So putting that together, it says that 4 times the first vector plus 3 times the second vector minus the third vector will equal the vector u. You can check it, 4, 3, and minus 1. So 4 of these, so that's 4 minus 3, that does equal 1, and then you can keep going and checking all the other ones that you'll get 1, 2, and 3 from that combination.